Now let's keep in mind that now we're talking about the conditional proposition. If P then Q, in this case our P being the president is in the White House, Q the president is in Washington D.C., and hence our conditional is if the president is in the White House, then the president is in Washington D.C., which is telling you that if the president is in the white circle, the White House, since Washington, D.C. surrounds the White House, think of this as a map, then if the president's in the White House, the president's in Washington, D.C. Now we can see the truth conditions by using a truth table that we introduced earlier in the lectures on the predicate logic. And remember the way we set the table up. That is, we have a column for P's possible truth value, Q's possible truth value, and one for if P then Q. And since the truth value of if P then Q is determined by the truth value of the components P, the propositions that make up if P then Q, P and Q, we know that there are 4 possible combinations of P and Q. True, true. Second line, true, false. Third line, false, true. And the last one, false, false. And if you don't see this, you can knock yourself out trying to find another combination of values that we don't have. Now, if P is true and Q is true, if P then Q is also true. Right? If P is true and Q is false, notice it's telling us if the president's in the White House, then he's in Washington, D.C. But if we know that if he's in the White House but not in Washington, D.C., in other words, it doesn't depict our diagram up here, that is the case where we would know that is a case where we would know, and it's going to turn out to be the only case in which the proposition if P then Q is false. Now, if the antecedent, if P is true, if the antecedent is false, it doesn't matter what the consequent is, right? Because if it's false that the president's in the White House, that if then is vacuously true. It doesn't matter true or false. But the critical thing to note here is that there's one case in which an if-then statement is false. There's only one to remember. That is when P is Q, P is true, the antecedent is true, and F, the consequent, is false. This is the only case we have to remember. We can remember the rest of them are all true. And what we're going to see is this is going to help us see how the inferences using if-then, the valid inferences, the good inferences, are going to work. And to just kind of give you an idea about where we're going with this, if we take a look at the predicate logic valid patterns on the left, we saw all A's are B's, X is an A, therefore X is a B. I hope we're all familiar with this by this time. Second one, all A's are B's, X is not a B, therefore X is not an A. Remember the second one, we're going in the not direction, from right to left. So that's how we get the not A. And then we have all A's are B's. All B's are C's, therefore all A's are C's. Well, if we look at the first one, all A's are B's, X is an A, therefore X is a B, we're going to see that with regard to conditional propositions, hypothetical propositions, there's an analogous kind of inference, which is something called modus ponens. It's sometimes called affirming the antecedent, because the second premise affirms the P, which is the antecedent. It says the antecedent is true. And notice if P then Q, like A and B, P kind of like the X's in A, therefore Q. Modus ponens, a good form of inference. And we're going to go through the example, and we'll go through the truth table, and we'll understand in several ways. But I just want you to see that just to recognize the pattern, they're going to be perfectly analogous. So I told you earlier on, if you could remember 6 inferences, you're going to get through most of the valid inferences that we in fact need. Second one, resembling, the second premise is it's denying the consequent. Analogous, we're in the not mode. Going now from right to left is okay in the not mode because left to right is the normal mode. So if P then Q, not P, not Q, therefore not P. That way, when the inference goes that way, it is a valid pattern of argument. It is a valid inference. And then if P then Q, if Q then R, therefore if P then R. Final good valid form of inference, valid pattern, and you see the analogy between these and the valid patterns that we had in the predicate logic. Now remember, in the case of the predicate logic, and we're just going to worry about the first one, we had the argument all A's are B's, and the way we have to draw the diagram is if circle with A's everything that is an A. I'm pointing with my fingers. You guys can't see my fingers, so I'll have to use the cursor. Anything that's an A is also in the circle of B things. And if we know that X is an A, what we're going to do is we're going to put an X in the A box because that's where it belongs. But if we see X is an A, clearly X is a B. Well, now let's look at modus ponens and see how it's similar, or affirming the antecedent, as it's sometimes called. If P then Q, P, therefore Q. Let's see the diagram. If P then Q means all cases in which P is true are also cases in which Q is true. So the circle with Q has to be around the circle with P. That is, there could be more cases in which Q is true, but not P. In the same way, if we're thinking about if the president is in the White House and then he's in Washington, D.C., well, we know if he's in the White House, he's in Washington, D.C., but there are other ways for it to be true for that he's in Washington, D.C. He could be in the Capitol. He could be in the McDonald's in Washington, D.C. But now we know is if all cases where the P is true are in the little circle and the little circles contain the big circle, if we know P is true, we do know that Q is true. And let's take a look at the truth table for modus ponens. And there was our truth table for if P then Q, and let's see what we're talking about. We say if P then Q. So we know if P then Q is true, so it has to be either the first, the argument, the respective truth values have to be either the first one, the third, or the fourth, because we know if we're using if P then Q as a premise, we know that that premise is true. So it just excludes the second case. Now, if our second premise is that P is true, we can only look at cases where P is true. And let's look at, if we're looking at P, it's true in the first two cases, not in the last two cases. So from these two premises, we see that we have to have both of these true, and there's only one case in which both if P then Q is true and P is true, and that is it is the first case. So it's not the third, it's not the fourth, where if P then Q is also true, so it has to be the first case, which also tells us that Q is in fact true. So this is the reason the truth table works in this case. This is the table, this is showing why it is a valid pattern of inference. Let's now take another look using the circle diagrams. This modified what are Venn diagrams. There was a logician named Venn who came up with this idea using these diagrams. So let's take a look. If P then Q tells us P, all cases of P are true are also cases in which Q is true. So Q is a bigger circle around P. Now the second premise tells us that P is true. Well, if that's the case, if P is true, we can conclude that Q is true. And if we want to think of an example, if Beyonce is a mother, then Beyonce is a female. All cases where Beyonce is mothers, Beyonce is in a mother case, that's true there, then she's in the female circle, the bigger circle, exactly like the P and Q above. And my diagram jumped a little bit ahead. We know that Beyonce is a mother, so we know the green, where we are, is in the green circle. Well, if we know that she's a mother, we also know that she is a female. So it looks like modus ponens is a valid form of inference. That is, that the conclusion will follow from the premises in the case of modus ponens.